All right, I think we're going to go ahead and get started. My name is Jeff Mealiff. I'm a program manager in the Office 365 team, and I am also responsible for Exchange virtualization, support guidelines, as well as, pardon me as I clip my mic back on here, support guidelines and best practices guidance. So we're here today talking about Server 2013 virtualization best practices guidance. And we'll go ahead and jump right in. I'm expecting to have maybe 15 minutes at the end for questions. We'll see if I can stick to that schedule. If not, same as what I did in my sizing talk earlier, I'll throw my email address up here on the screen at the end. And I'm also going to be down at Mappy Hour wearing one of these awful, awful, awful shirts. Along with many of my colleagues. So feel free to come down and share a tasty beverage. So I'm going to start off with a quick refresher on supportability, what is and what isn't supported. We'll go into some hot topics. I know there have been some interesting things in the community recently around virtualization. We'll talk about some of those. Some of this you may have heard before. In general, what I try and do in this session, even though we do it pretty much at every conference we present at, is try and keep things current, make sure that we're still talking about the topics that are coming in via questions from the field, as well as things that we're seeing in support cases. So, there may be a little bit of repetition here for some of you who've been to previous versions of this talk, but we'll try and keep it as interesting as possible through that section. I'll talk about a little bit around sizing and deployment recommendations, so things you need to be aware of when you think about sizing implications for a virtualized solution, and just general deployment recommendations around things to expect with virtualized Exchange, and then we'll jump into questions. If you do have questions at the end, and I am going to ask you to hold questions until the end, I am going to ask you to use the mics here in the middle of the room so that we can make sure we get your question on the recording. All right, so before we start off, I always like to start off with a little quick poll. Very interested in who's doing what out there today from a deployment perspective. So of the folks in the audience, who's deploying on physical, not virtualizing at all today? Okay, got a few. Usually that's actually a lower number in this session, but that's interesting. So the folks who are virtualizing, Hyper-V? Okay. I think I know the answer to the next question. How about VMware? All right. That was somewhat expected, but good to see. All right. We love Hyper-V. Go Hyper-V. So this is one that I don't usually ask, but I am interested in the answer. So who's actually using IaaS today? And I'm talking about for production use. I know some folks are using it for dev test, lab environments, that sort of thing. Who's actually deploying Exchange in production on Azure, Amazon Web Services, anything else? One, anybody else? All right, two, okay. Good, glad to see that's a small number. We'll talk about that in a minute. And then I asked the production question. So who's using it for test, actually? Anybody using it non-production use? A few? Okay, great. Okay, so this is usually the question that we get. Should I take the leap? Should I virtualize or should I stay physical? Historically our guidance has been physical's great. We should absolutely go physical. Well, not really here to change that today, other than to say simple, right? I've noticed looking at the Twitter feed from the conference, simplicity is coming across as a theme in a number of sessions, particularly the architecture sessions. Absolutely applies here as well. We think simple is better across the board for Exchange. And simple may have different meanings in the context of virtualization. I think it means don't do it, personally. I think it means that, in general, adding a hypervisor layer in between Exchange and hardware adds additional complexity that you don't really need. But if you're getting something out of that complexity, then maybe it's a wash, or maybe it's a win for you. It's really going to depend on the specific situation, the specific business requirements that led you down the path of virtualizing. So it's, like it says here, not always going to be the simple solution for everyone. We understand that it absolutely makes sense to virtualize Exchange in some cases, particularly smaller deployments, right? If there's no way for you to consume the capacity of the physical servers that you're deploying, well, we would much rather see you have multiple Exchange VMs across multiple servers and using that additional capacity for other workloads so that you can take advantage of the high availability functionality within Exchange, right? We'd rather have you, instead of trying to just have a standalone Exchange server for a small deployment and dealing with all of the risk of failure of that one specific machine, deploy a few smaller VMs on multiple servers and enjoy the benefits of a DAG. You're going to have a better experience with Exchange generally if you deploy that way. So something to keep in mind. And we just want to make sure that you're going to get something out of virtualizing. Like I said earlier, if you are seeing some benefit from that hypervisor layer, that's great. We want to make sure you're seeing that benefit and not just virtualizing so that you can check a checkbox and say, yes, along with everything else in my data center, Exchange is virtualized. That's not the right reason to virtualize it. Your boss might tell you it is. But from our perspective, we want to make sure that you're actually using some of that additional functionality that you get. Live migration, vMotion, these types of things. Maybe the advantages that you get from those and allowing you to patch other hosts, et cetera. Patch hosts without bringing down workloads. So let's go through supportability real quick, and then we'll get to the fun stuff. So minor change on this slide if you've seen this session delivered before. So in terms of what we do support, all versions of Hyper-V. This actually used to be a nice long list of versions of Hyper-V. And we finally got to the point in conversations with the Hyper-V team about the testing that they do and the assurances that they can provide that we're comfortable with just saying any version of Hyper-V, you're good to go. That means that as new versions of Windows Server are released, we're not going to be going out and updating this guidance to say, yes, we support that version of Windows as a hypervisor for deployment with Exchange 2013. You can just assume moving forward that you're good to go. That's not to say that you can immediately go and deploy on that version of Windows with native Exchange. We're just talking about the hypervisor, the version of Hyper-V. And then, in addition, the third-party hypervisors like VMware that are covered under the Server Virtualization Validation Program, the SVVP program. We support all of the Exchange roles for virtualization. I used to joke all 2 of them. Now we have Edge back, so all 3. So no limitations there. But I'll say it again. I'm on a roll today. Multi-role deployment. Everyone should be doing multi-role, even when virtualizing. This used to be a challenge with older versions of Hyper-V, where we had a limitation of 4 virtual CPUs per VM. Made it really hard to realistically deploy a multi-role server. You really need a little more scalability than that. We don't have that limitation with current releases of Hyper-V, and we don't have that limitation with VMware either. So there's really no reason not to go multi-role with virtual machines as well. Storage. We require block-level storage for Exchange, same as when Exchange is deployed on physical hardware, not virtualized. And essentially for 2013, we have the same storage requirements for virtualized Exchange as we did for 2010, with one exception, and that was the introduction of support for SMB 3.0 for storage of VHD files. That doesn't include NFS, doesn't include down-level versions of SMB. It's just SMB 3.0. And we'll talk a little bit more about that in a few minutes. We support host-based clustering. And this means taking a set of virtual machines, could be running Exchange, could be running anything, just virtual machines, and running them in a cluster at the hypervisor level. So that if a physical machine that's running one or more virtual machines has a failure, and it will eventually have a failure, that VM will come up on another hypervisor host automatically. That's what we're talking about there. Absolutely supported. Keep in mind that it doesn't provide high availability for Exchange in the way we think about high availability. I'll also go into some detail there in a few minutes. We support migration, so that's vMotion, vMotion, live migration, those types of technologies for Exchange. And we highly encourage you to run JetStress on your virtual machines as well. We didn't used to support JetStress running in the guests. We do currently. So please do that to make sure that the storage that's sitting behind your virtualized infrastructure is fully capable of giving Exchange what it needs to be successful. So the link down at the bottom, that's the official link to our supportability guidance for virtualized Exchange. I'm going to cover migration and with a little bit of extra specifics here, just because this is a common area of confusion. So there's some guidance out there around, I think it talks about cold boot and things staying online. And we tend to get a lot of questions around what the support statement about migration really means. The key thing to remember here is when it comes to migration, live migration, vMotion, what we're basically saying is these technologies are supported as long as Exchange stays online. Basically, the Exchange server doesn't disappear from the cluster, doesn't go offline from a network perspective for the duration, and that you're essentially not taking a memory snapshot of the virtual machine at a point in time, migrating, and then bringing it up, which you can think of as what Hyper-V's quick migration does. That's not supported. Live migration, vMotion, the technologies that keep the VM online, we totally support that. There's some best practices for making sure that you're successful doing that you need to be aware of, and those will come later, but totally supported. Don't use quick migration. Bad juju. It does not play well with Exchange. So, not supported. Do not use dynamic memory, memory over commit, any technology that does funky things with memory behind the scenes. We don't support it. Exchange really hates having memory taken away from it behind the scenes. It really does not like it. And so we do not support it, period, for Exchange 2013. Our best practices guidance says it's not supported. VMware's best practices guidance for deployment with Exchange says don't use it. So please, do not use it. Historically, we've seen a lot of support cases around Exchange performance due to these types of technologies. Now, I'll say that from the perspective of lab deployment, these types of technologies do make a lot of sense. When you haven't actually gone through the sizing process for a production deployment, you don't know how much memory you're actually going to need, particularly for CAS. Not so much for Mailbox, but for CAS, for Active Directory, for other machines that you're deploying in a lab, dynamic memory is great. Fantastic. But for production, go through sizing, use the calculator, figure out how much memory you need, and lock that memory into place. That's what you need. That's what Exchange gets, always. That's the key. We don't support hypervisor snapshots. I'm not talking about VSS. I'm talking about going into the Hyper-V Manager tool or into VMware and saying, I want to take a point-in-time snapshot of that VM that I can go back to later. Doesn't work well with Exchange. We don't support it. And I'll talk through why a little bit later as well. Same with differencing and delta disks, the storage that enables that technology, not supported. I'm going to skip over apps on the root. It's fairly straightforward. It's a Hyper-V thing. Can't really do this with VMware, but don't go running SQL on the root. And then we don't support significant processor oversubscription. So that means basically making the VMs believe that they have access to a lot of resources that they don't actually have. Not good for Exchange. Exchange 2013 is hungry. Hungry for resources. It's hungry for memory. It's hungry for CPU. It's not so hungry for I/O anymore, which is great. We continue to make that better. But for CPU and memory in particular, it's hungry. And we need to give it what it needs in order to have a successful deployment. We don't support Hyper-V Replica. There's a few different reasons for this, but just keep in mind at the moment, we don't support Hyper-V Replica. We continue to have ongoing conversations with that team about whether we will in the future. But essentially, Hyper-V Replica is doing is providing the same functionality for a DR solution that we provide within Exchange with our log shipping. They're doing it for applications that don't have that built-in functionality. Right? So Hyper-V Replica essentially allows you to take any application that you can virtualize and build a fairly cheap DR solution. And that's fantastic. We love that. You'll get a much better experience if you use the functionality that's native to Exchange for Exchange DR. That's the key. All right, hot topics. Start off with another quick poll here. Who deploys VMs using NFS? Admit it. Come on, there's got to be a few. I know there's some of you. All right, a few. I'm not going to hold it against you. I'm not going to go cancel your support contracts. It's all good. All right, I saw about 10 hands. Who wants to? Who would it help? That's kind of what I thought. OK, so there's about 3 hands. Anyone out here want to admit that they've had issues deploying Exchange VMs on NFS? A few hands. OK. All right, let's talk about hyperthreading. Just kidding. OK, so it's been a little bit of a fuss made in the community lately around NFS. So I figured we'd get out and not really get out in front of it because it's been going on for a couple of months, but at least talk to it here and have an open dialogue about what the real story is, the reasons we don't support it, and what we're doing moving forward about it. So the real story here. We've had issues historically with NFS. We've had perf issues and reliability issues. I'm fairly confident these days that the issues that we had with perf and NFS solutions are probably long gone. I mean, I've dealt with storage perf issues for years. There's usually solutions to pretty much any storage perf issue that involve throwing more hardware at the problem. But I'm not so worried about perf these days. What I am worried about is reliability, and I'll talk to why that is in a second. Because we had those perf and reliability issues historically with NFS, we elected to not do the engineering work to really make it feasible with a physical Exchange deployment to use NFS storage. In other words, to directly store your Exchange database files, logs, whatever, on NFS. We said, not supported. We're not going to make it work. Don't do it. So when we began supporting virtualized Exchange, really with the 2007 release, we carried that support statement forward. We said, OK, if you can't do it with physical, we don't want you to do it with virtualized Exchange. Realizing that there were ways to make that at least sort of work, right? You can expose VHDs, VMDKs to virtual machines that are sitting on NFS storage in the background, but look like essentially a block-level storage device to Exchange. We specifically elected not to go down that path because of the history there. So in the past, that's the level of detail that we've taken it to, but we need to take it to a little more detail now, given some of the questions that have been raised. So talking in detail about reliability, there's 3 areas that we've had problems with that are super critical for Exchange and making sure that we maintain the reliability, the consistency of data within Exchange, within the store, within Jet. So 3 areas of concern: forced unit access and write-through. And what we're basically talking about there is the ability of Exchange to say to the storage stack beneath it, I'm issuing you an I/O, and I want that I/O to hit the disk. I don't care how many layers of caching there are in between me and the disk. I want you to do exactly what I'm telling you to do. And when you come back, I expect that it was done. That's what that means. Now, anytime you have something sitting in between Exchange and the disk, any one of those components can essentially say, OK, sure, whatever. I'm going to ignore that and do whatever they want to do on the back end. Right? And we've had issues with NFS storage where that has happened, essentially, where I won't say we've been lied to, but where components have not done the right thing from a data integrity or an I/O integrity perspective. Write ordering refers to the application having an expectation that when it issues a bunch of IOs down to the storage sitting behind it, that those IOs are going to occur in the order that we asked for them to occur. That hasn't always happened. And that can be a challenge when you have expectations about the order of IOs to log files and databases, as an example. It is very important, right? Torrent IO protection refers to the expectation that an application has that if I issue an IO to storage, that IO is not going to get split into multiple IOs, some of which might actually occur and others don't, right? So if I issue an IO to a log file, and I need to have the expectation that IO is either going to complete or it's not that half of it's going to complete. That's a bad thing for an application like Exchange. So those are the areas we've had problems with. And I'm certainly not going to stand up here and say that all implementations of NFS have this problem, or all components that could sit between Exchange and NFS have one or more of these problems. I have no way to know that because we don't test with every single piece of that test matrix. We just don't know. But we have seen these problems historically. So we basically require some guarantees from the storage sitting behind us in order for Exchange to deliver on its promises around keeping data safe. That's the key here. And we don't feel that Exchange can really make those guarantees when we can't rely on storage to provide these things to us. So let's kind of put it all together and see how this all plays with a hypervisor. So this is a diagram that essentially describes a few physical Exchange servers talking to some NFS storage solutions on the back end. Very simple diagram. Got some Ethernet switches in between. So this today doesn't work. There's really no way to configure it. It's not supported. We don't like it. There's no real way to do this. So Mr. Smiley here goes and says, well, I know how to make this work. I'm going to go out and stick a hypervisor in between the storage and Exchange. And I'm going to drop some VMDKs or other virtual disk files on that NFS storage. And I'm going to essentially trick Exchange into using that storage. So I've magically virtualized everything there, and I've moved my databases onto these virtual disks over here within the virtual machines. And Exchange theoretically runs happily. Now, the key point here is that once we do this, assuming that the NFS storage solution that I have up here on the right is going to do the right thing when it comes to those requirements that I mentioned, assuming that, well, the hypervisor in this case is really responsible for guaranteeing things, right? It's now kind of that initial point in the storage stack in between Exchange and the storage. It's what's tricking Exchange into seeing block-level storage when there's really just some files on the back end that may or may not be handling I/O correctly for us. Our concern here is that the hypervisor is something that changes. So it would not surprise me in the least that there are versions of hypervisors out there today that do exactly the right thing and make this work. And this is the reason, in my opinion, that we have some customers who've deployed in this way and have been entirely successful. The challenge, though, is figuring out which versions of which hypervisors with which drivers actually work perfectly. And we don't have a good way to do that today. So the challenge here is that things might work now. They might not work next week. They might have not worked last week. And we want to make sure that things always work, right? We don't want to be reliant on something that we have zero control over and really no sort of like certification or validation program in place to ensure the integrity of the data sitting in Exchange. So it's a huge risk. So now what? We don't currently have any plans to change our support stance. The fact that there were 3 people in the audience that were actually thinking that this might help them from a deployment perspective helps, to provide some positive feedback to me that we're headed in the right direction and not actively trying to make a change here. We're certainly open to taking feedback on that. There are some potential solutions to this, none of which are great, none of which I think everyone would be super happy about, to make some of these things more possible than they are currently. But like I said, we're not actively going down that path, and there are other areas that I think would have a greater benefit to everyone in this room for us to go spend time on and try and make a better story around Exchange deployment. So if you are deployed like this today, it's a risk, and it's up to you to figure out how to manage that risk. Exchange may be working beautifully today. I would highly recommend that as you consider patching, upgrading components within that storage stack, that you do some very careful testing to make sure that you're good to go. And when I say testing, what I mean there is reliability testing. Right? The areas that I'm most concerned about around this scenario are areas where storage goes offline suddenly, those types of things. Go unplug the power from your storage subsystem. Hopefully it's got some redundant power, so unplug both power supplies. While Exchange is actually running in test, doing something, understand what happens in those scenarios. That's one example of a test case. These are the types of things that you should be thinking about to help mitigate that risk. The other thing to call out is, being unsupported means essentially that if you call into Microsoft support, if you need some help with your storage, with Exchange running on this solution, that essentially CSS is going to provide commercially reasonable support. Right? They're going to try and help you. CSS doesn't, pick up the phone and say, "Oh, you're running on NFS? Sorry, click." We don't do that. We're going to do everything we can to help you. But if it does look like there's a bug in Exchange, for example, you may be asked to reproduce the bug in a supported configuration. And if it's some sort of data integrity issue, we may have some issues with being able to get you back into a good situation there. But support does the right thing, right? We do what we can to help. I will call out one thing. Please don't lie to support about the storage that you're running. It just drags things out. When all this was kind of starting to come up in the community, there was a lot of attention being paid to this. I went and did a search through our support database for issues that had come in, and the first case that popped up, I won't name the customer. Hopefully they're not here. If they are, they don't recognize this. Somebody called in and said they basically were having database corruption issues. Huge amount of data, multiple databases got corrupted, and they needed help from support. And so support helped them bring up some dial tone databases, which immediately got corrupted. And they were asked what type of storage they were running. Well, they mentioned they were virtualized. I'll not mention the hypervisor. They were using iSCSI, and they hadn't had any issues previously. And so they brought up some more dial tone databases, and those got corrupted. And this went on for about a week of trying to figure out what the heck was going on and troubleshooting through the system. And then it came out, well, we're actually using NFS. We have plans to move to iSCSI, but we're on NFS right now. And once that came out, they got some fairly straightforward suggestions to move to iSCSI quickly, and that particular problem was eliminated. Now, this was on an older version of the unnamed hypervisor, and like I said, there certainly are ways, from what I understand today, to make this work. But it's a risk that it won't work tomorrow. So be aware of that and be careful. And our guidance is always going to be stay supported. So there are alternatives, and we'd highly recommend that you go that direction. So one potential option here that I'll throw out is SMB 3.0. You get a lot of the benefits of an NFS deployment from SMB 3.0. We've done a lot of testing with SMB 3.0 from a reliability perspective. That's why we're confident enough to say that it's supported. Now, SMB 3.0 is primarily available via Windows Server 2012. It's also available now via other storage providers that are providing access to whatever their underlying storage is via SMB 3.0 protocol heads in their controllers. So that is fully supported for use with Exchange. Only for storage of VHDs, though, not for direct access from a physical Exchange deployment. So worth considering if you're thinking that you're getting some benefit today from that type of a deployment. You might want to look into whether or not this is an option. It may even be an option that's already available within your storage solution. So something to explore. All right, let's talk about IaaS. So IaaS deployments are definitely possible. Please don't do them. If you're going to go down this path, and I'll give you my simple guidance. Go to Office 365. Now, I realize that's not an option for everyone and that there are legitimate reasons. There are things that we don't offer, types of flexibility that we don't offer today in Office 365 that might lead you down the path of deploying in an IaaS provider so that you have the full flexibility of an on-premises Exchange deployment, but have the benefits of having that deployment hosted elsewhere, right? Don't have to worry about hardware. That's someone else's problem. You're just paying a single bill for all your hardware, your network, your power, your space and cooling, et cetera. That's great. There's some specific challenges with Exchange for production use. Dev and test, we're not so concerned about. We think this is actually a fairly good solution for dev and test, assuming the cost model makes sense. I would argue that sometimes it really doesn't. Sometimes these solutions are actually very expensive to run Exchange. So from an Azure perspective, I'll just start off with our offering here. We don't support Exchange production deployment on Azure, period. It's in our virtualization guidance. And there's a caveat there, the production piece. Feel free to deploy dev and test environments for labs. That's all good. No problem with that. There may be some performance issues. Don't expect perf to be the same as what you would see in an on-premises deployment. But if you're OK with that, if you're just trying out some functionality, doing functional testing, by all means, feel free. So other than Azure, a couple of things I would call out. We don't have a specific support statement that says IaaS provider X is or is not supported. There's no program that we have in place to do that today. But what we do say is if that IaaS provider is virtualizing Exchange, and the vast majority of them will be, you need to make sure that they're actually following our guidance. In other words, they need to be running a hypervisor that's on the server virtualization validation program. Okay, that's key. You need to make sure that they can meet our disk performance requirements. That means maybe running jet stress on that IaaS provider. Now, I realize a lot of them actually charge by the I/O for storage. I've actually done a little testing on Azure, and it was kind of entertaining to see the bill for that. I'm glad I didn't have to pay it. So I realize that may be onerous, but having said that, if you don't do that, you have no idea what you're going to get, right? Even if you are going to a provider and saying, I want to buy guaranteed I/O at a particular level, trust but verify, right? The general way that that's going to be sold is we're going to provide you with that I/O, and if we miss our SLA, well, then there's a penalty. Make sure that they're not just selling you something that they're also reselling to somebody else because they made the calculation that the penalty might be not that big of a deal. So make sure that you're getting the perf that you require. That storage is shared storage. Almost certainly. You think about from the perspective of the IaaS provider, how are they going to roll things out in a way that makes sense for them? They're going to be providing some shared storage. So even though you may be getting the right level of perf at one point in time, that doesn't mean you're always going to get it. You know, the cloud is supposed to be elastic, right? They're able to dynamically tune things based on demand. Workloads are coming up, going away constantly. And you don't really have any control over that. You don't have any control over where your VMs sit relative to other things that are running. So that's a risk that you need to figure out some way to manage. Outbound mail flow can also be a problem here. So the challenge with outbound mail flow is around sender reputation. So when you send outbound messages from these types of solutions, you're generally doing it from an IP that's part of a shared pool of IPs for the service, right? So if I go and deploy a virtual machine in Azure, I'm going to get an external IP address that's associated with my VM. There's a bunch of NAT going on between the internet and between my virtual machine. So I'll have an external IP that's exposed on the internet that will appear to be the source of those connections. That IP is going to be used for other things. And it's within an IP range that you really have no control over. So you don't know if the VM sitting right next to you that happens to be using a very close IP in that range, or maybe even the same one, is a spammer. So you don't know if the IP that's being used for outbound SMTP from your deployment is going to end up on block lists at any moment in time. Large challenge there. So that means you then need to think about how you route all your outbound mail. Do you need to go through a solution like EOP maybe? There's a number of other third-party solutions that are options there as well to basically guarantee that you are who you say you are to that other service, and then rely on their reputation to successfully deliver your mail. Something you wouldn't necessarily have to do with an on-premises deployment. So those are kind of the main concerns with IaaS. There are other lesser concerns, I guess. Be more than happy to talk through some of those at Mappy Hour downstairs. In general, we're gonna continue the message that if you are interested in the cloud, Office 365 or other similar offerings, where you're basically buying mailboxes, you're not buying infrastructure, are the best way to move to Exchange in the cloud. You get the nice advantage of not having to manage the infrastructure, make it our problem in the case of Office 365. So one last point around supportability and hot topics. So we've had some issues lately around host-based backup. This refers to essentially taking backups at the host level of virtual machines. So this would be something like on my Hyper-V host, going and running Windows backup and saying, OK, back up all the VMs on my machine and expect that all of the data associated with those VMs gets backed up as well. You can do that, but it requires some very specific things in the stack all the way down to Exchange for this to work properly. And I don't have the time in today's session to actually go through that detail. I'm working with Tim McMichael right now on putting together a blog post that will explain best practices for this. So you can expect that soon. But if you're doing this today, my advice to you is test your backups. Make sure that you're actually backing up what you think you are. And if you are considering going down this path, understand the recommendations from your backup vendor to make sure that what you're doing is integrated with Exchange. They actually have components that are doing the right things to talk to Exchange, make sure that log truncation is happening correctly, et cetera, so that we're doing essentially an application-aware backup and not just potentially backing up the system without Exchange. So be very careful of this. All right, so let's go through sizing and deployment. So virtualization adds overhead. It's not free. Don't ever let anyone tell you it's free. And I'm not talking about licensing. I know nothing about licensing. I get to live in that world. It's a very nice world to not have to worry about licensing. So what I'm talking about here is hardware resources. Virtualization always adds overhead. You're adding something in the stack in between the application and the processor. That something has to do work, and that adds requirements. In the case of Hyper-V, we say that's about a 10% impact to your CPU. In the case of VMware, they have their own guidance, and we recommend you use their guidance for this. They have a, I'll just say, in general, follow your hypervisor vendor's guidance around deployment. Right? I'm talking about generic best practices here. The hypervisor vendors have great guidance for how to successfully deploy and operate Exchange on their platforms. We recommend that, as wherever it makes sense, use their guidance as well. So follow VMware's guidance or another hypervisor vendor's guidance for this here. The role requirements calculator actually makes it fairly easy to make these calculations. So there's actually a drop-down box right below the multi-role option. Multi-role default is yes. Virtualization default is no. But if you're going down this path, you just change that to yes, and it will add the 10% for Hyper-V. There's another field a little bit farther down where you can override that value if you're using a different hypervisor. So that allows you to really quickly calculate what you need. Hyperthreading. I joked we were going to talk about hyperthreading earlier when we jumped into NFS. We'll actually talk about it now. So we have specifically said we don't want hyperthreading on for physical deployments for Exchange 2013. The guidance is a little bit different when it comes to virtualization. So the reason we don't want hyperthreading turned on with physical deployments has to do with not wanting those extra logical processors visible to us. It changes how the .NET framework allocates memory, causes some issues there. When it comes to virtualized deployments, you can absolutely leave hyperthreading turned on your physical servers. But when it comes time to allocate resources to the virtual machine, only allocate as many virtual CPUs as you need from a sizing perspective. If you go into the calculator and you say, I'm going to deploy 8 CPU machines with some spec int number for the amount of horsepower there, actually deploy 8 virtual CPUs. Don't deploy 16 virtual CPUs just because you can. What that's going to end up with is essentially the same behavior that we see with hyperthreading turned on physical servers, and a bunch of additional memory allocation that shouldn't be happening. So that's the key there. And the diagram here is showing 4 physical processors with 4 cores each. So there's 16 physical processor cores on the server. Use those for sizing. When figuring out how many CPU resources you have available to use for Exchange. The rest of it, those logical processor cores, which will be double the number of physical processor cores, the extra 16 are gravy. We may be able to take advantage of some of that from a CPU throughput perspective, but don't use it for sizing. There's no guarantee of what that's going to add on top of the real processor resources. That's the key. And then on top of that, don't oversubscribe, basically. I'll say it a few times in the remainder of our time here, particularly around CPU. Memory, we don't support any sort of oversubscription, quote unquote, but for CPU, we do support a little bit here. The best practice, don't do it. We want to make sure that Exchange can always get to the resources that it needs when it asks for them. Exchange 2013 is hungry. I also mentioned that earlier. It wants a lot of CPU. Okay? If it can't get to those resources, there's a few things that typically happen. I've got them listed down here in small print at the bottom. You can see delivery throughput reduction, growing queues. I don't know about you guys, but I don't like having to deal with draining queues. It's not a nice thing. And in general, from an operational perspective, the only thing you ever want to see in queues are outbound messages to the internet that can't be delivered for transient issues, right? In general, the mail flowing through your Exchange system should be delivered as it's coming in, right? We don't want to build queues. Content indexing throughput reduction can occur, right? If CI gets CPU starved, it can get behind. We don't like that. We want CI to be as up-to-date as possible, both to be able to respond to searches, as well as to ensure that it doesn't have to go catch up, because that can actually result in some I/O impact as well. We want it to be up-to-date. And then store RPC processing, ROP processing, can slow down. And that results in end-user impact. You can actually see those requests actually being processed slower from a client perspective. So don't want that either. That results in help desk calls. Not good. Don't oversubscribe CPU. So in general, memory sizing is not impacted here, other than the comment that I made earlier that we don't support any sort of dynamic memory, memory overcommit, whatever you want to say there. There are a lot of options for configuring hypervisors around NUMA. Exchange knows nothing about NUMA. We're not SQL. SQL loves NUMA. NUMA helps SQL scale to great heights. We are all about scale out, not scale up, so we have not gone down that path of trying to ensure that, that we can take full advantage of the scale benefits of becoming NUMA aware. So we're not NUMA aware. If you expose the NUMA topology information, the memory topology information on your physical servers to Exchange, Exchange isn't going to do anything, but the OS that we're sitting on top of will actually perform some optimizations in the way it works. So it doesn't hurt us to click that checkbox and say, yes, expose the NUMA topology information, or to try and essentially run the VMs that Exchange is running within on specific NUMA nodes. By all means, feel free. That's great. We will see some benefit from that. But when you hear about all the wonderful scalability benefits that you get by exposing that NUMA information to the application, it doesn't really help us. So no benefit there. For storage, we obviously need low latency. We need HA as well. No surprises there. And I guess the last point is probably the most critical thing here. We want you to be able to follow our physical sizing guidance. A lot of the things that I talked about earlier today. Follow that same process. Apply the output of that to your virtual deployment, right? So the output of that's going to be essentially how many servers you need, the size of those servers, build your VMs based on that, apply the CPU overhead that I mentioned, and rock and roll. That's how it goes. Now, when we start talking about multiple VMs running Exchange or something else, we need to make sure that Exchange gets what it needs. So you can, I mentioned that we don't want to Exchange oversubscribing anything, but it's quite possible that other workloads that are running on the same physical host as Exchange are oversubscribing, because they may not have, how can I put this, as well thought out guidance as we do. So the best way to deal with that is to reserve resources for Exchange. Hyper-V lets you do this. VMware lets you do this. I'm willing to bet every hypervisor on the planet lets you say, this VM has to have these resources always. Go ahead and do whatever you want. Boogie down with the remaining resources for all the other VMs. That's the way to solve this problem. Lock in those resources for Exchange. I realize that means that your private cloud deployment becomes a little less dynamic or elastic or whatever words you want to use. I threw private cloud out. Do I get points for that? I'll say machine learning as well. Does that help? All right. I'm sure you can do some great machine learning on your private cloud. So use resource reservations to make sure that Exchange gets what it needs, and that'll solve that for you. You also want to make sure that when we think about co-location of VMs, that you're not deploying a bunch of Exchange VMs on the same physical host. The same guidance that we have for physical deployments, where we don't want people scaling up and deploying many tens of thousands of users on active users on a very large server, applies here as well. And I know there's some desire to do this, because the hardware that you typically use to virtualize is big hardware, right? I know these are 40, 80 core machines, right, with huge amounts of memory and a bunch of storage sitting behind them. That's That's the way these deployments happen. So there's a desire to use as much of that as we can, and there's always some interest in deploying a lot of Exchange users on here. Spread things out. That's our request. Basically, we want the fewest possible Exchange VMs running on a physical host at a time. Use the other resources on the box for other workloads. It's totally cool. But spread out those Exchange VMs for HA reasons. Right? We want the impact of a physical host failing to be as minimal as possible on the Exchange system. And that kind of brings us up to failure domains. So don't co-locate Exchange with Exchange's dependencies. Don't put, two Exchange servers that have the 2 copies of your mailbox databases on the same physical host along with your Active Directory servers. People do it and call into support and get upset that things aren't working. It's not just about Exchange, it's about our dependencies as well. And with some of the modern options that are available in the storage space with virtualized SANs, where you have an actual VM running in the infrastructure that's acting as a storage controller. You also have to think about that as well, where these things are placed. All of this impacts what we call failure domains. In the physical world, we used to think of blade servers as being a big concern around failure domains, and they still are. Losing a backplane or losing redundant backplanes, killing all those servers simultaneously, not a great thing. But that's actually a fairly simple example compared to all the different components that go into a virtual solution. You really need to think about anything in that solution that can possibly fail and impact things enough that you lose multiple copies of your databases or experience any sort of a failure that can actually impact availability. Make sure that you're spreading stuff out as much as possible. Witness servers also matter here. Can't tell you the number of times I've heard of folks not thinking about where their witness servers live and not placing them very intelligently. So consider that. So host-based failover clustering I mentioned earlier is being supported. Absolutely is. You can totally use it. It's great. It doesn't do much for Exchange, other than, there's 2 cases. One of them is you're running a standalone Exchange VM that's not in a DAG. So this means that if the physical server that VM is running on fails, well, we will essentially lose that VM. It will come up from cold boot on another hypervisor host and be online after some period of time, however long it takes to start it up. That's not really high availability. That's probably better than going into the server room and switching on the server manually. Sure, that's an improvement, but it's not high availability. You get high availability from a DAG and mailbox database level failover or switchover. That's where we want the high availability investments and the design to come from. So really what you're going to get from failover clustering high availability, or host-based failover clustering, I should say, is a DAG node that is on a physical server that fails, coming up quickly, relatively quickly, on another server that hasn't, that's operational, and allowing replication to get back up to speed and get those copies in a state where you can deal with a DAG switchover or failover in basically a faster period of time versus that particular virtual machine getting more and more out of sync and needing more time to catch up. That's really what you get. So if you want to deploy it, you certainly can. It's supported. Just be aware of what you're actually getting. It's not true high availability. That's why it's in quotes. I'm going to go fairly quick through this just because this set of slides has been in the best practices guidance for a while. I'm not going to harp on this too much, but and I've already harped on it a bit. Don't use dynamic memory. Don't use memory overcommit. Essentially what happens here is memory gets ripped out underneath Exchange. And depending on the version of Exchange that you're using, we're either going to end up with some database cache in the page file or with database cache getting shrunk pretty dramatically. with 2013, what we'll typically see is database cache in the page file, which is now allowed to be dramatically less than it used to be. If you were in the sizing session earlier, you know what I'm talking about. So this is the graph that I like to show of dynamic memory having a nice impact on exchange. So this is a graph of RPC average latency over time. This is a graph of available bytes. This is dynamic memory coming to a virtual machine running Exchange and saying, hey, there's another VM that's on, that I'm responsible for that needs memory. You lose. I'm going to take memory away from you. So there's a couple other lines that I could add on here that actually show the paging that's occurring when that available bytes counter basically goes to 0. But what's happening here is through the ballooning process that dynamic memory uses, a good chunk of the memory that Store was using in this case just went away, which resulted in Store doing a bunch of its work based on data that's sitting in the page file, slowing everything down. So that's user impacting, right? People will feel that. And some of those things that I mentioned earlier that can happen when you get CPU starved can also happen in this case. Everything's going to slow down. Not good, so don't do it. Coming towards the end here of best practices before we get to some questions. So when we're doing migration, the biggest concern that we have around migration is making sure that DAG nodes can keep talking to each other while they're being migrated. The way migration happens, and there have been some tweaks to this technology over time, is that essentially we're taking a snapshot of memory on a virtual machine and copying it over the network to a different physical host. And when we start the migration operation, we're kind of starting at the beginning of memory for that virtual machine and keeping track at that point that we start the copy of any in-memory pages that are changing. So we do a copy from start to finish, and while things are happening behind the scenes, we're also keeping track of things that have changed. Then we do another iteration, and we copy the changed pages. And then we keep copying changed pages, changed pages, changed pages. And that amount of data that we copy in each one of those cycles gets smaller and smaller and smaller until it's a really tiny number of pages that have changed. And then we have what we call the brownout period. This is how it works for the two major hypervisors that we're talking about today. That brownout period actually results in the virtual machine being unavailable. It's, you try to ping it, and you may see some ping failures there, depending on how long that brownout period lasts. But it comes up on the other machine, starts from essentially that same point in time where the brownout period began on the source machine, and everything continues along just fine. The challenge is if that brownout period lasts longer than the cluster heartbeat timeout within Windows failover clustering. If it does, then that DAG node essentially gets evicted from the cluster, and we assume that it's offline, and we do what we should do when when a DAG member goes offline, we fail over. We don't want to do that, right? Live migration, vMotion implies that everything continues operating, right? We don't want to do we don't want any sort of failure mechanism to kick in when this occurs. So there's a few things we can do here. One of them is make sure that we have the right level of network bandwidth to support that process. In the latest version of Hyper-V, the Hyper-V team actually did some great work to compress memory data being sent across that has a really nice impact here. Makes it much less likely that we're going to run into these problems. The other thing you can do is adjust the heartbeat timeouts. If you have to, you can. We'd recommend in general that you avoid doing this, but there is a way to do that, and there's some parameters here up on the screen that affect the thresholds for communication within a subnet. And if you go do a search on TechNet, you'll find the equivalent parameters for nodes that are on different subnets. So in this case, this is saying, this is referring to the default, which is 5 seconds. It's saying try 5 times 1 second apart. The 1,000 is in milliseconds. So if you wanted to make this 10 seconds, which, by the way, is about as high as we would recommend ever going, you could either adjust the threshold to 10 or the subnet delay to 2,000. It's just a multiplication of the two that affects the timeout. Don't use snapshots. I mentioned it earlier. The issue here is that we're effectively operating a system that's replicating data between nodes. And we're not designed to handle the case where you're replicating between machines, and one of those machines, at some point, goes back in time. That's what snapshots enable. Any sort of dynamic system that's doing replication like that is not going to respond well unless it's specifically designed to deal with that case. We're not. That's something that's happening underneath Exchange that we're not designed to deal with. So that's the reasoning for why we don't support snapshots. And then I guess the last point around best practices and tuning for virtualization. In 2013, we have a component called workload management that is designed to take advantage of the resources that are available on a machine and do what we call trimming the peaks and filling the valleys. So there's essentially a change over the day or over the week of how the system is utilized. Right? There's peak times during the day. It'll be different probably for everyone in the room. And there's a set of work that we want to run really well during those peak times. That's interactive work for transactions that are coming from user interfaces, basically from Outlook, whatever. We want that stuff to be snappy. We want to optimize for that when that load is heavy. We don't want to be doing stuff at that time that we could do later. Things like background maintenance tasks. But at the same time, that load is going to go down at some point in the future. That's when we get into the valleys. And at that point in time, we have resources left on the table that we can take advantage of. So that's when we start running these maintenance tasks. The interesting thing with virtualization is that if you've got oversubscription of resources, if you're basically allocating CPU that doesn't really exist, Exchange doesn't have a really good view of what resources are actually available to it at any moment in time. And you end up with us not being able to make great decisions about the right thing to do at any moment in time around running background tasks because things seem to be in the valleys, or optimizing for more critical work when things are running hotter. So this is another really important reason to not oversubscribe CPU with 2013. We didn't see that as much with 2010, but it's definitely a concern with 2013. So we do support virtualization. We have a few limitations. I've attempted to describe every single one of those limitations today, but there's a whole lot of additional functionality that I don't go through in this session that's available within hypervisors that can work great with Exchange. So be aware of that. Not always the right choice to virtualize. Sometimes it may be. But simplicity is the key. Right? You're going to get the best benefits from Exchange. You're going to have the best Exchange deployment if you keep it simple wherever possible. Don't oversubscribe. Give Exchange the resources that it needs, that it's sized for through our normal sizing process. Make sure that it can always get to those resources. You're going to have the best Exchange experience. And be aware that there are features, functionality within hypervisors that may be similar to things that Exchange has natively within the application. In general, the closer you get to the application when it comes to these features, the better off you're going to be. As an example, disaster recovery with Hyper-V Replica versus Exchange. We're able to provide a much better experience in the case of a disaster. Wow, that sounds horrible. We can make your disasters awesome. We're able to do some things there that ensure that Exchange can be better off because that logic is closer to the application by using a DAG, by using that functionality that's built into the app versus relying on something higher in the stack. That's the key there. So even though there is that functionality available in the hypervisor, it's not necessarily the right choice for us. So keep that in mind. So with that, I've got 10 minutes for questions before we all get to go have some beer. So questions, Mike's in the middle, and go ahead, Devin.
Hi, Jeff.
Hi.
So there's a raging debate going on at this moment on Twitter about a certain virtualization backup vendor whose name shall not be mentioned but rhymes with dream.
Yes?
And the promises that they make about how you can back up virtualized Exchange without having to put an agent inside Exchange. And I was wondering if you could speak to how that specific scenario, agentless backup of an Exchange virtual machine, ties into the support boundaries. I mean, I think I know what the answer is, but I would like to hear you say it.
Awesome. Without picking on any one vendor that you've, basically just named without naming. Yeah, thanks for that. I guess what I would say there is I mentioned that we are actively working on some specific guidance around host-based backup that will completely cover that scenario, and I'd rather just leave it for that because it's not a simple answer. Okay. What else? There's got to be some other questions. You do have to get up though and stand in front of a mic. Yep. In the back first.
When you say don't load up your Exchange and supporting servers on the same host, are you talking blade or chassis?
Doesn't matter. Now, hang on. So the guidance applies equally to both, but anytime you're deploying on blades, you also have additional considerations. Right, the entire blade chassis is a failure domain, and so you need to consider the risk of that blade chassis going offline simultaneously. Basically, you just need to add those additional considerations into play, but the guidance is generic to both. Yep, up front.
My boss got an email that Exchange could be deployed in Amazon AWS services. What is your opinion about this? You probably will cover it.
Yeah, so I think the slide on IaaS solutions specifically said at the top it can be done. In fact, I'll jump back to it. It can be done, but you shouldn't. So that's my opinion and our best practices guidance. That was really towards the front. Yep. So production use generally not recommended. So the key thing to be aware of for any IaaS provider other than Azure, with Azure we specifically say at this time not supported. You need to make sure that they are following all of our best practices. Well, I shouldn't even say that. You need to make sure that they're following our supportability guidance for virtualization. In the case of Amazon, because they're running VMs for you. So you need to make sure that they're using a hypervisor that's on SVVP. You need to make sure that the storage that they're using follows our guidance around being block level, et cetera. That's basically the answer. And if you're not getting the answers that you want there, you're going to be in a similar situation to the NFS comments that I made from a supportability state, where if something goes wrong, it's a risk, and you kind of need to figure out how you're going to manage that risk. Tony.
Jeff, nice to be here. I've been bringing some of your remarks to the Twittering public, and a certain amount of whining has come back from the NFS community.
Mm-hmm.
Who basically
are you talking about right now or over the last month or two?
Yeah, right now. Yeah,
awesome. All right.
It's like my phone has been jumping quite a lot. Basically, you're a slut. But basically, they're saying there's no issues with virtual disk on top of NFS. You're lying. We're not worried. Customers want to use NFS and they want Microsoft to support it. In lieu of it, we support it for them. And basically, we're brilliant and Microsoft sucks dirty canal water. Now, that is a condensed version, the Reader's Digest version of all of the comments that I've received.
Awesome. I'm looking forward to catching up on that.
I think it would really be good if you could just summarize and maybe, once again, because some of us are slow learners, certainly these folks are, maybe if you could summarize once again NFS.
Somebody tweet that real quick. What Tony just said there.
I know I am a slow learner about NFS because these guys have been telling me all the time. You know, it's like, I've written about this at least twice in the last year, and I've tried to get the message across, but they don't understand. Jeff, 2 sentences. NFS is?
2 sentences or 2 words?
2 words is easier to tweet. NFS is?
Not supported.
Not supported. I just wanted everybody to understand that. It is not supported.
I'll leave up that slide while we're answering other questions. I think that first line is applicable to this conversation. We're not actively planning to change the support stance. So I have certainly had some conversations with folks who are not in the room in the partner community around this, and we will continue to have those conversations. I think one of the important points here is around the number of people in the audience who raised their hands when I asked who wants this, which was a grand total of 3. It's a very small percentage of the people in this room who really care about virtualizing Exchange that want this. You know, when it comes down to it, we prioritize investments that we're going to make. And in order for us to go down the path of supporting this, there are certain things that we're going to have to do to make sure that all of our customers are going to have a great experience with this. It's not something where I'm going to go personally and just flip a switch and we're magically going to support it. We have to be 100% certain that we're good to go across, you know, all the hypervisors that we support, all the storage solutions that we support, or that we have some sort of a program in place to make those determinations. So there is some investment that has to happen, and we're choosing to make those investments elsewhere at the moment, given the actual level of interest. So hopefully that's, you know, nice and transparent about why we're going where we're going. Does that help, Tony? All right.
Okay, on the subject of storage, what is the best practices for thin provisioning, thick provisioning, lazy zero, eager zero, all of that?
All right.
Or pros and cons, or whatever you want.
Yeah. So I used to be able to stand up on stage when I got the thin provisioning question and say, don't do it. Microsoft doesn't do it, so you shouldn't do it either. But now we do it. The wonders of running a service at scale. So thin provisioning has some pluses and minuses, some pros and cons. So we do, thin provisioning also has a bunch of different definitions. If we're talking about building VHDs and VMDKs that are going to grow over time, you know, that is what some people consider thin provisioning. We consider that to be a no-no because the perf cost associated with growing those VMs is actually fairly dramatic, which is why we actually require fixed-size VMDKs or VHDs. If you're talking about on the SAN end of things, doing thin provisioning, that's a little bit different. And generally, the cons around that are really around the monitoring and making sure that you are watching your system closely enough that you don't end up in a situation where you have a really dramatic storage issue that you can't respond to fast enough. And you know, we've had that at Microsoft. Internally in our IT deployment, where we've actually had bugs in products that have resulted in mailboxes growing dramatically, very suddenly. And you know, when you're thin provisioned and all of a sudden your mailboxes are double the size they were yesterday, that can be a little bit of a challenge. So that also kind of falls into the risk management category. If you are guaranteeing to someone that they have a mailbox of some size and you don't actually have the storage to back that, and they decide that, well, we've got all the, you know, I have a PST that I want to import, and because I don't want to have that on my local disk, how can you predict that was going to happen? You can't really do that. So if you've got enough control over your solution that you feel that that the risk is low of hitting those situations where you're going to run out of space, then it may be an okay solution. But it's a risk, and it doesn't really fall into the simple mantra that we've been bringing up here either. I get from a cost perspective why it's why you may want to do it, especially with a shared storage solution. So hopefully that helps.
An easy one. Preferences for VHDs or RDMs?
So VMDKs or RDMs? That's okay. VHDs are pass-through, or yeah. Follow your hypervisor vendor's best practices guidance. There really is no preference one way or the other. There's some benefits in some ways to doing VHDs or VMDKs. Some interesting flexibility around, usually around like the like live migration, as an example, with cluster shared volumes. You can have a dramatically faster live migration process, typically, if you go in that direction versus doing pass-through, where you actually have to fail over access to the pass-through drives individually. Things like that will impact that decision. But from a perf perspective, I can tell you from the Hyper-V perspective, we don't care. We see basically the same performance from VHDs versus pass-through. And I'm not going to speak to benchmark data for VMware. They'd need to speak to that. But it wouldn't surprise me if they see similar performance. Hopefully that helps. All right, we're over time. So somebody can go buy me a beer for my NFS statements. Thanks.